Great, and then you're welcome to the very first video uh, about machine learning. So today I'm going to give a little background to machine things, and then we can leave it from there, and then we'll move on. This is going to be about 15 different videos. Trying to break down machine learning in the simplest form that you can ever find. And so if you have not subscribed to this particular channel, please do so, and then you can share whatever content that you have here, like it, and then give me a thumbs up, support the channel to grow. Alright, so machine learning, what is it about? Like the concept, machine learning basically means that you have a machine that is learning like the way we human beings also learn. Okay, so I'm just pulling up something small. Okay, so if we are talking about machine learning, we are talking about the fact that we as human beings, we get the opportunity to learn, and we learn things over time. So if I have to demonstrate that this machete is red, it has to be through learning. And then we have to all agree that the color is red or it is brown. So over time we learn to realize that this color is this, and that color is that, and that color is this. That's we human beings. There's also an opportunity for a machine to also learn about something using the whatever features that the thing comes with. For instance, if you consistently show the machine or the characteristics of a mango, anytime the machine sees any object that looks like a mango, the machine will say that it is a mango, and then it is not a pineapple. So machine learning is basically about how machines are able to learn the features of any object, and then they are able to make prediction near exactitude the next time that particular object is being spotted. And so this is just a very narrow way of defining machine learning, but this is somebody's classification of machine learning, which I thought maybe necessary. Credit to the one who did this. I just snipped it from someone. So, and also we're looking at different types of machine learning, and then we have supervised learning, unsupervised learning, and of course we also have the reinforced learning. Now with the supervised learning, the data points are already known, or the data characteristics, the features of the data is already known, and so the features are fed into the computer, and then the computer learns those particular features and what they are describing. So the next time the computer sees it, then the computer is able to identify that this is this or that is that, and that's supervised learning. And then under supervised learning, what kind of models, or what kind of algorithms, or what kind of method, let me put it that way, do we employ? We employ regression analysis. It can be linear regression, it can be polynomial, it can be multiple regression, it can be logistic regression. All that we are trying to do there is to kind of like do some kind of regression analysis. In regression, what are we possibly looking at? You are looking at how one variable explains the other variable. So there are two variables here, and then we are trying to look at how much of one variable influences the output of the other variable. And so that's regression. For instance, if I have one variable that is dependent on the other variable, so it means I have one independent variable and the other one is dependent. So I'm looking at how much influence the dependent variable gets from the independent variable. Or if there is a unit change in the dependent variable, how much change will I see in the independent variable, and then vice versa. So that is what regression is all about. And then we also get the opportunity to measure whether this particular relationship that we're trying to look at, is there anything significant or it is not significant, and what is the accuracy. They are all part of it. So we have the linear one, that is direct link, direct access, link that we are looking at, and we have the polynomial where we do not have the direct relationship. Now we also use decision trees. Decision trees here, we are saying that, okay, we have all the human beings, and we are saying that, well, if you are tall, we put you to one side. And then that's how decision trees are worked with. So you want to classify humans all the way up to a particular point. So first of all, we will say that we put living things on top there, and we say that, well, if you are a human being, then go to the left. Now when we get to human being, we are looking for tall people. We say that if you are tall, go to the left. When we follow that one, when we get to, and then if you are tall and then you are fair, then go to the other side. Then we move to the fair people and say that if you are tall and you are fair and you come from this region, go to the other side. So decision tree is like you continuously follow a trajectory and then take out the unnecessary, what you are not needed, and then you follow the path, and then that is how decision trees are able to let us, come to a conclusion. Then we also have random forest. This is a model that is also used to be able to give us a prediction. Then we also use classification method, and under classification we are looking at k nearest neighbors, we are looking at trees, we are looking at logistic regression, I've mentioned it, and then naive bias, and then the SVM. These are the various ways to which supervised learning is being done in machine learning. So we also have the unsupervised learning. At this point, the data points are not being described. The machine doesn't know anything about the data. What you simply do, you feed the machine with the data, and the machine will simply learn on the data. So I have students of a particular university, then I have their characteristics and whatsoever. I have the data points already, so I just feed it into the machine, and the machine will decide to look at all the features that the machine can identify and classify or group the students or cluster them based on whatever features the machine has identified as as similar or as differences. And so how are we able to conduct unsupervised learning? We do that by clustering. And so we also can do that by, let's say, by clustering, we can classify all the people who are coming or who are having a particular feature. We can cluster them based on something. And to be able to do clustering, we can use SVD, we can use PCA, that's a principal component analysis. We can also use K-means. And of course, under unsupervised learning, we can also do something we call association analysis, where you are looking at a priori, and then you are looking at LPV, what is FP groove. And of course, the last part of unsupervised learning is also the hidden Markov model, which is also used a lot under unsupervised learning. We will break these things down when we get to the studio. The last part of machine learning is reinforced learning. The reinforced learning, the machine keep on reactivating itself or learning on the data. So part of it is like there are some features already that has been given. For instance, you have a CCTV camera that can interpret the data straightforward. So when it sees a human being, it can say that that's a human being. But it can sometimes see something and may get confused. Is it a human being or it is not a human being? So it comes like in the form of a question, and then you would have to confirm it using other means. And then when it is confirmed, the machine add it as a feature or as a characteristic. So the next time the machine sees the same thing, it will know that it is a human being. Mostly what you see in reinforced learning is like when you take Google, and when you Google for something, Google may not be able to give you, and Google doesn't have that information. It may not give, it won't just return empty and say that it is not there, but it might give you something related to that. So Google knows that, okay, I don't have this, but per the wording you have used, you might be interested in something like that. And so when you begin to accept the suggestion they have given to you, that's reinforced learning. It adds to it that anytime somebody is looking for this information, it's possible the person could be looking for this kind of information. And that's why when you Google for one item, Google can give you over 100 links. And then it's based on reinforced learning. That is why it's able to, give you additional information, which they think you might be in what they're interested. So that's basically how machine learning is being done. But for you to be able to understand machine learning, this information that I have spoken about, how are you going to feed this information into the computer for the computer to work? Then it requires a specific language, because the computer doesn't understand all languages. There are specific languages that the computer understands. And one of the basic language we are going to use in this instance is R programming. Now, in R programming, we're going to get to R Studio momentarily, and then we see how machine learning is being implemented. So let me simply take us to, so this is my R Studio. I've already said that this particular listen is going to be, we're going to have as many videos as possible. I'm planning about 15 different videos, but I have something quite small that I would like us to have a look at. So I'm just coming to that particular portion. And so in machine learning, if you have been following my tutorials, I have done a lot of things with respect to the basics to R programming. But nonetheless, I'm still going to carry on with some few things that we need to know about R. So for instance, where I am now, I am in R Studio. And then if you are not familiar with R Studio, what I am simply doing here, I'm just brushing off some few things here. So I brush off around here. You can just come and then click on this. So where you have all this white thing here, it means this is, well, I mean, the first pan, this is the second pan, the third, and then the fourth pan here. So they are just sliding windows in R where we are able to. So I can write all my scripts here, and then I can, if I run the script on this particular pan, then I see whatever that is happening in this particular pan, which is called the console. Here we call it the environment, and then this is where the files are, and then of course this is where we write the script. Now, if I come here, let's if we are talking about machine learning, like I keep saying, before you can say anything about machine learning, there are some basic steps that you need to follow. First of all, the data. You need to get the data into your into the environment in which you can communicate to the computer to understand whatever that you are doing. So, for instance, the first step is you have to get the data into your computer. And so, if you get the data, the second step is you have to make sure you clean the data. So if I'm talking about the first step is you have to get your data, what is it, into the computer, and then the second step will be you have to clean the data up, or which we call the data wrangling. So you have to do what is called data wrangling. So no data comes in the form that you like. You will have to make sure that you reshape the data into the type that you want, and they all come under data wrangling. All right, so when we get to data wrangling, and then we can then begin to say that, okay, we want to split the data into a training data and then a test data, okay? And that's under supervised learning. Then, so it means the third step will be, what is it, splitting the data. The data into, what is it, you have train and then test data, and then that is it. Then the next thing is to try and do some kind of training. Training the model on the trained data, or using the model on the trained data. And of course you need to test the model on the test data, and then you need to do what we call refining the model, and then that is all. So these are the basic steps that we are supposed to follow when we are doing machine learning. Today, what I want us to pay attention to is getting the data into the computer is simple. If you've been following my tutorials, if you have your data seated somewhere, there are several ways through which you can get the data into the computer. So if I'm looking at number one, for instance, how do I get the data? That's like importing the data. There are several ways of doing that. One is I can import the data. If I have the data seated somewhere, I can just come to this side, and then if I'm importing it, if it's a CSV file, then just come here and click. Then I look for where the data is, and then I can import it. Now, the other way is I can just copy the data and paste. It's like I have some data seated somewhere, which I am going to try and see what if I can just import it and use that one to demonstrate whatever that I'm doing. So Okay, so I have some data around here, so I'm just going to copy it, and so I'm going to copy it like this. So I'm getting back to RStudio. So when I come back here, I'm getting the data into the environment, and so this particular data is about, let's say it's a mosquito. So I'm just going to leave it like that, and then or I can just leave it this way, mosquito data. So this way, then by now you should know some of these things, the assignment operator. And what am I going to do? I'm going to read the data. I'm going to use a delimiter. So in that case, I'm just going to enter here and say clipboard, because I've already copied the data into my clipboard. So I'm going to read it from my clipboard right now, and that is it. So if I do this, if I run it, the data has been run properly, and that gets into my clipboard. And so the data is now here. I can actually, and then you see how the data looks like. Yeah. So I've copied the data into my clip. What is it? As you can see, I mean, the data is all here. It appears is a different data I have copied. So let me check that pretty soon, and then I'll get back to you. So I'm just coming to come and look at where the data is. Okay, here. So I'm copying. So I have copied the data, or should I do it once again, and then I copy it. Then I go back to RStudio. Then what is it? I just run this, and then that's run properly. Let me try and then print this again. Of course, so I have my data. It has been read into my into this particular variable that I have created. So you can just come here, and then I'm going to check the dimensions of that particular variable, mo underscore data, and then it is telling me that but it comes in the form of a vector, so which is not supposed to be so. So I'm going to try and see what if I can copy it again. This is just a way of like copy and paste, which I like to do often. So I don't know if I have done any. Okay, so I will come here and say the separators should be equal to this, some space over there, and then I'm going to come here, then do it all over again, and check this. So now you can see that that's where the mistake was. Never be afraid of mistakes. So when I was reading the data, I didn't provide the separator, so it came as a single file. But now that I provided the data, you see that it's now a data frame. So now if I check it, or if I try to print it out, you see that it will come in the form of a data frame, and that's voila. So that's what I was looking for. Yeah, so you can see the data is now seated around here, and so now I can begin to work with it. So that's one of the steps that we have finished the first step. So we have gotten our data into our computer. So the next thing is the data wrangling. I mean, data wrangling is, what are we supposed to do? We need to check to find out whether this data is in good shape or it is not. For instance, if I scroll up, you notice that there are some NAs. You see, there are some NAs here. So let me clear this. If I should print the data, or if I should say I want to look at the summary of the data, so you will notice that so it's mo underscore data. So you notice that there are some NAs somewhere. We have NAs which are there. The other way to check to see whether you have NAs is to just say is .na, and then you will just put the name of the data set under it. So under more data, and then you run it. Okay, and then you simply, and by running, control enter. So you can see that wherever you see true, it means that there is an NA. Wherever you see true, it means there is an NA, which means those data what is not available. So you see that you can see true. I just asked a question: is there NA in that data set? And then I can see true. So what that means is you need to clean the NAs. If not, you cannot do anything with it. Okay. So how am I going to clean it? I can create a new variable, and I can call that new variable. I can say mo underscore d1, and so that's the first. I'm just going to clean it. And what am I going to say? I'm going to say na dot omit. So I want to remove all the NAs. And why am I omitting it? I'm omitting it from this, what I call the MO data. So, and I'm packing everything to this new variable. So I'm going to run that there. And so you see that the new variable has run properly. Now let's come again and check whether in the new variable the NAs have been omitted, have been removed or not. So I'm going to come here and say again, is there NAs in the new variable that we have just created, which is mo underscore g1. It's actually g1 like this. So scroll up here and find out. You see that it's saying false. You can't find true anywhere. It means the NAs have been removed. These are part of the processes or what we call data wrangling, like data wrangling. So you can actually do this, and then you are able to to make sure that you remove all your. And then the next thing for you to check is to find out whether. So you say something like structure. You find out the structure of the data. So I'm just going to find out the structure of mo underscore g1, and so that way it's going to tell us which ones are integers, which ones are characters. So we can see that column 2 or variable 2 treatment is a character. And then I need to check all these things, because before you can perform or you can do the rest of the work, you need to know what kind of variables I am dealing with, and which ones can form my independent and which ones are my dependent, and are they characters, are they numbers, because functions work based on the type of data or the data point that you are dealing with. Okay, so I have just checked that, and that what I've seen that column 2 is a character, the rest are numbers and integers. So good to go. So at this point, if I don't want the column 2, I can actually just remove that. How do I do that? I can just come here and set mo underscore d1. That's the data set I am talking about, and then I can just come here like this. So if I have 1, that's column 1. If I do this, that's column 2. If I don't want column 2 out, I just say -2, and in that case I am taking column 2 out. So it was, the variable was on column 2 treatment, it was on column 2. If I do that, and then I can create a new variable, and then package into that particular variable. So I can now say md1, that's my new variable here, and then I'm just going to do this. And so what I've done here is that I am saying that I am packing the whole of this data or data frame into this new variable here, excluding column 2. So if I run this, so you will notice that column 2 will not be there any longer, which was treatment. So if I come here and I decide to check structure of like md1, you won't find treatment again, and you may not find characters anywhere. So you can see that there's no treatment any longer, and there's no characters in the description. Now we were having 14 variables, now there are 13 variables because we've taken one variable out, one column out. So these are all part of data wrangling. And then if there are some rows that you are not interested, you can use the same approach to take those particular rows out, and then whatsoever. They are all part of the data wrangling process. Now if you are done, the next thing for you to be able to do is to now split the data into training set, and then you can also you use it for, you can split it into training, and then you can also split it into test. So you just use one code to be able to split it. Now that takes us to another function that we're supposed to use, how to split the data. Now I don't want to, that particular data, I'm going to work with it for long, so I'm going to use different data set and then show us how to be able to do data splitting before we can go ahead and then learn. We can now come and apply the same technique around this particular place. And let me advise, in easy data analysis, you don't work with the same data directly. Sometimes you just leave that data aside, simulate something that looks like that data, and then apply all your functions and all your packages and then all your algorithms on the simulated data. When it works, then you already have the script. You now pull in the real data into it, and then you work with it. That's why I don't want to work with this data that I've imported, because it's a real-time data. Okay, so what do I do? How do I split data? Data splitting. So we just created some few things here. So this is a data frame that I've just created. So I'm just going to highlight the whole of this block and then run it at once. So the data frame is here. I can just do like this, and then you have a look at it. So it's a data frame of IDs, name, gender. Then I have the date of birth. So this DOB means date of birth, and then the state where you are coming from. It's actually the data that I just picked from somewhere, an algorithm I just picked from somewhere, reference to that. And so now, how do I select? If I want to select some, this particular one means that I'm selecting some few rows. I just want to select, like, just say 3 rows. And so you use this curly bracket. Anything on the left of this, it means rows. So if I run that, I'm selecting only 3 rows. So you can see that I have just selected the 3 rows, which are here, down here. Okay, so these are various ways through which. Then what about if I want to select rows by list of index? So this one, it means that you are not just you are not selecting the rows that are following each other, like they are not in sequence. So you use the vector to be able to do that. So if I run this, it means I'm selecting row 3, row 4, and then row 5. These are all part of the ways through which you can actually split your data. Okay, so you see that it's going to print those specific rows, and so it has printed row 3, row 4, and row 6, and so you can see it around here. So these are all part of the manual ways of analyzing data as well. So you can also select the rows by index or range. So this one, if you are selecting from row 3 to row 6, that's when they are following. The rows are following each other. Then you can do this. So if I do that, I'm selecting from those particular rows to the last row. So now here I can also look at we are just going to look at the first 3 rows. This is another way of selecting the first 3 rows. So you can just say head the data frame, and then you say 3. You are looking at the first 3 rows. So that's also the same way. I could have just packed that into a new variable. Okay, so there are various ways through which you can do that. You can also look at the last 3 rows, and then this particular one, we have a data frame, but for here we are selecting the rows by name. Do we have any row by name R square, R to the R3? Let's try and see. So the R3 is actually not available, and so you can see that there's a row there which is not available. You can see N is. Then we can also select rows by list of their names. So you have row 3 and then row 6. You see, row 3 and then row whatsoever. So if you run that, let's see what we're going to have. So we're going to have all that over there. These are all part of the ways through which you can select your, or you can split your data the way you want. Now, for the sake of time, I'm unable to run all this, but here, let's say what we have here, you can actually select part of the data. I think I need to explain this based on a specific column identity. For instance, here my data frame is here, and I'm saying that if you enter that my data frame, on the row side, look for anything gender, and that particular gender I'm looking at male. That's what all this is saying. I'm going to enter into this particular data frame, and I'm entering the column called gender, and in that particular column select all those that are male, and so I'm going to print only the male. So you can see that I have only male around here, and that is it. So I can work with this. So another way of doing that, you can also select the rows by a list of column values. For instance, so I have my data frame here, so I can enter into my data frame and look for this column. So data frame $sign and state means you are selecting this specific column called state. And then I am trying to find out that within that particular column, this one means member of. This percentage in R program, it means member of. Is there any of this which is a member of state? So it's going to check within the state column if there's anything they call CA, AZ, and then PH, is to print that out. So it's also part of the selection. And when I do that, you're going to see our CA, AZ, and then PH. It will select those ones out. And that's selecting rows by list of column values. So, and then you can also use is.element is a function where you are, so this is my data frame, but I'm saying that is there some element within the state column which is the same as this, so to print that one out. If it is not, it will return something 0. So another way you can use subset, and so we have a subset of data frame, and so I'm saying that okay, I'm going to subset this particular data frame, but I am looking within the state column and find out whether there is a member, whether any of this is a member of the state column, and if it is, if it matches, then you print that one out, and then it will simply print the same thing out. So you can, this one, that's a div plier where you can use filter, so you filter is out, is practically the same thing there. And so that is how we are able to do filtering. Now there's other ways of doing filtering which is much more deeper. So come and look at something here. This is an inbuilt package. It comes with dplyr, so I have to activate the dplyr package to be able to so I'm just going to come here to activate a package. You should have installed the package already, so dplyr is around here. So when I do that, the Star Wars data set is now is a data package which is found within the dplyr package, you see. So now we are going to look at what that is. So I'm just having a glimpse of the head of that particular data, and look at how it looks like. It's actually a table, or it's a form of a table of 6 by 4 columns, okay, by 14. So we have name, height, and whatsoever, the mass, the hair color, the skin color, eye color, birth year, sex, gender, and then quite a number of variables. So let's look at how to be able to split or to be able to also subset this data. So I can come here, maybe this one will be better. If I want to catch a glimpse of all of it, it's going to give me all the characteristics of all the variables which are there. So the columns are about 14, the rows are about 87. And so it gives me the characteristics of all of them. They are characters, integers, and some of them are doubles. Double means you have a decimal point. What is it? In computer language, we call them double. And so in that order. So we have all of them like this. So let's look at how do we use the dplyr package, which I have already activated, or I have already loaded into the R environment by ticking it here. So how do we, so here, what we are simply doing here is that we are piping out, we are picking portion. That's what that means. We are picking portion from this particular data frame. We are picking, what are we picking? We are filtering, we are going to the species column, and then anything that matches human being, then it will return it. So if I run that, it will return all that matches humans. So I'm going to pull this out. So come and look at the species column. You can see that it has selected only the humans. These are other ways through which we are able to so we can see that it has selected only humans. Here you could have changed it to something else. Now what does this code mean? The whole of this code, what does it mean? It means that we have a data set, which is the data frame called Star Wars, and we are piping out something from that particular place. What are we piping out? We are filtering out species, but we're not filtering all the species. We are filtering the species that matches with humans. So we are filtering only humans out. That's all that it means. So I'm simply saying that with the filter function, go into the stars, filter out species that matches humans, and that's all. Then it will print it out for me. That's what we have here. Then we can also filter species that are also, and in this case we are using a logical operator here. That's n. So you can filter two things at the same time. You can filter humans, and then if that human has the eyes are brown, or the human is short, or this, then you can use the logical operator called n here. So here I am filtering species, which is droid. Is also a species, but I'm not filtering all the droid. All the droid that have what eye color, and then that particular eye color is red. Filter that out, and that's what. So it's going to filter only. You can see the eye color here on this particular column here. See, so it will take all droid, but under that it will just pick only the droid with the red color, and that's what that means. We could have used or. It's also a logical operator. So in that case, we are looking for the species which is droid, or anything that has an eye color of red. So let's see what that is going to give us. You see that it gives us a little bit more, because it's not only droid that has red eye color. So we are saying that pick droid and any other or anything that has red eye color, and that's what that particular code means. So you can actually combine a lot of the logical operators to be able to filter out your data. And then here we can look at stars. We can look at the data set. We can filter almost the same as what I was explaining. So we are going to go into the eye color column, and then we are going to pipe out something that is related to this particular vector here. Anything blue, anything yellow, anything red, based on colors. So what are we piping? We are looking from the eye color group, from the eye color column. So this is the eye color column. So we are picking blue eyes, yellow eyes, and red eyes there. If you don't fall within that, so you see that it picks blue, yellow, and then red. Okay, so of course we can also filter based on height. We can say if you have or based on greater than or less than, or they are all what logical operators. So what I'm going to do is I'm filtering out height, but if your height is not up to or is not greater than 250, then you will not be filtered out. So if I do that, I run that particular line, so that you see that it's only one. If I run the next one, so we are looking at between 200 and then 230, and then that will also come in there. And so these are the various ways through which we are able to split our data. You can split the data based on a lot of there are some techniques through which you can split the data, but these are the general ones I've just given to us. It's not all the time that you feel or you split the data on just 70, 30, 40, 60, and then whatsoever. There are various ways you can split your data in terms of machine learning. And at this point, I'll leave it here, and then tomorrow we will look at how to be able to now split this data into 30 and then 70% as trained data, and then of course test data, and then we will try and see where the next video will end. But tonight I hope you've learned something small. It's just a basic introduction to our machine learning. Great, thank you, and I hope to see you tomorrow. Bye bye.